Hi, I'm just about to connect this old induction motor up, and I thought, well, I'll record a video. I'm not too sure of how much interest it will be, but maybe someone will find it useful, particularly because it has a couple of windings where we will have to determine, I think I already know, but we will have to determine what those windings are on these wires. Also, other things, like, are we going to use these crimp terminals, or are we going to use these, this is a termination tool for bootlace ferrules, which I really like. Actually, these are the ones we're going to end up using. So I'll show you these as well. The tool itself is very cheap. More about that later. Cheap but good, actually. We use a multimeter as well to do a little bit of testing. So first of all, let's just have a quick look at the motor. I think it's quite vintage. It is an induction motor, and hopefully you can just about make this out. So it's mains. UK mains, 230 volts. It's a fractional horsepower motor, so only 1/6 of horsepower, so it's roughly about 100 watts it's pulling. It's going to pull, well, I don't know quite what the current will be when it starts up, but the startup current is always several times more than the running current. The RPM, 2,800 RPM, and unfortunately I don't have, I used to have a device where I could easily measure motor RPM. It was junk, basically. It was a cheap Chinese import, so I scrapped that. I need to get something that's more reliable. Of course, I could wire something up with my oscilloscope or frequency counter, but I won't do that in this video. Right, we're just going to concentrate on wiring this thing up. So at the wiring end, you'll see, by the way, that there's no cable clamp on this. I think that's a sign of the age of the motor. No cable clamp, so I've cable tied that down. I also sleeved it with this braid. I think it's fiberglass braid. Anyway, it's fireproof. Okay, and I've added in a protective earth as well, which wasn't there originally. So we're presented with 2 white wires and 1 black wire. Now I do happen to know what they are, but I'll just run through the process just in case you've got a similar motor and you're not too sure. So this is an induction motor. It's also going to have a capacitor. Look at this old vintage capacitor here. We're going to wire that in as well. And some of these motors, I mean, there's various different varieties, but some of them have a start winding, which is only temporarily there, just to get the motor spinning over, and then the start winding will deactivate through a centrifugal switch, and then just only the run winding. So that's fairly common, and then also there will be a capacitor on the start winding to throw the 2 windings out of phase, so it can actually predictably go in one direction or the other and actually manage to start up as well. This motor doesn't have a centrifugal switch. We could check that by if you open it up, but I know that it doesn't have a centrifugal switch. So, but it's going to have, as an induction motor, it's going to have 2 windings so that it can actually start running over. Now, so we need to determine which of these. Remember, that's protective earth, so we get rid of that. Which ones are the windings? Okay, so that's fairly intuitive, basically from the colours anyway. But we do need to do some testing now. If you're one of my students, by the way, you might be watching these videos anyway, even though it's got nothing to do with what I'm teaching. But let me just point out, these are the sort of multimeter probes that we normally use in the classroom, which are fine. But if we want to just probe onto these, it'd be much easier if we have something that's got clips on. So I'm going to use this type instead, and like I say, if you're one of my students, we do have these in the classroom just there. They tend to get damaged quite easily. This one actually is a little bit, it's all right at the moment, but sometimes it's a bit sticky. So yeah, so if you think these, if you're one of my students, you think, oh hey, that would be useful, then yeah, for next time you do some electronics work, then mention it to me. I can find you some. Okay. So what we're going to do, we're going to measure resistance. Now, resistance of the windings of the induction motor are normally going to be quite low. So, and we're measuring resistance. Doesn't matter which way around we have these. So I'm going to see if I can clip that on there. Yeah, okay, sometimes they pop off a little bit. It's not quite the right size, but and so I put it on 200 ohms. That's the lowest setting on this particular meter, and I'll just clip on one of the others, and we get a reading of 32 ohms or thereabouts. Okay, so 32 ohms, and then if I measure black to the other white, that's about 32 ohms as well. Okay, now and I'll draw this out for us in a little bit, but if I measure across these two white wires, then I'm expecting the aggregate of those two. So yeah, so 60 something. Okay. Right. Okay. And by the way, I have done an earth leakage test, a high voltage earth leakage test on this motor, but we won't be covering that in this video. Okay. So what are we going to have? Well, let's just quickly sketch it out. So I'm going to connect the motor to a 230 volt AC supply. Okay, 230 volt AC supply. And then we know, because we've measured it, we've measured that there are two coils or two windings. Okay, I'll just draw them like that. Okay, two windings in the motor. One of them is going to be, well, it doesn't matter. You just call them, winding one, winding two. It doesn't really matter. And what I said was that each one was approximately, it doesn't really matter too much, but each one is approximately 32 ohms. Now, if one of them was significantly different from the other, then I might be thinking, oh, well, one of them is a start only winding and one of them is a run winding. But because they're the same, I think they're both the same windings. Okay. Let's just connect one of them. Doesn't matter which one. We'll connect one of them up to the power. Okay. Now, what you're going to find is that if you connected that one, both windings would be to the same AC supply, so they'd both be in phase. If they're both in phase, then you're not actually going to get the motor to spin over. So we need to knock them out. So when I'm talking about in phase, I'm talking about, if this were the phase, if this were the supply voltage over one of the phases, and then if the other one were following exactly the same, then the motor wouldn't spin. So we need to knock that out of phase. To do that, we can just use a capacitor like so. Okay, so that's what we're going to do. And yeah, so when we measured the resistance earlier, we were just measuring across that winding, from that point to that point and that point to that point, and then we also measured. Sorry, you can't see that. We also measured, from there to there, which was going, in series across that winding now. Okay. Now, if when we actually wire this up, and if it doesn't spin the right way, what we can do is we can just swap over the supply. Here, the supply goes directly to this winding, but via the capacitor on this one. Or we can just swap that over, and then we can reverse the direction of the motor. So, should hopefully be fairly straightforward. And I'm going to use these Wago spring clip, I don't know what you call them. Okay, those things anyway. Let me just give you a close-up. I bought some of these for work as well recently. They are actually very good. So the Wago 222, and the reason why I also bought some for work is because we could knock up our own sort of custom test leads ever so quickly, and you can just lift those open and snap them down, and it's really good. I know that those chock blocks or terminal blocks are pretty easy as well, but these are ridiculously easy, and they're not really expensive, so you might as well use them. Okay, so this is my power supply. You'll notice, or my power lead, you'll notice that I've left a bit of tape around that because I find these, that's inherently dangerous if someone plugs that in. So to stop me plugging it in accidentally, I'm going to leave that on there until I'm ready. So yep, so this is the mains flex. I need to get these stripped. Now once you strip them, you could just put them straight into these Wago. I mean, that's how they are meant to be used. However, I quite like using those bootlace ferrules, because it makes it nice, you know, if I'm repeatedly connecting and disconnecting. So that's what we're going to do, and you might find it interesting anyway, vaguely. The ones that I reckon we're probably going to be using are the red ones. They're all, you know, they're coloured according to the size rather than any particular, you know, like live or neutral or anything like that. So we're going to use those ones, those little red ones. They fit. In fact, we might even be able to go something smaller than that, actually. So you want this plastic shell bit, you want that to just go over the insulation of the wire. So I reckon probably that's going to fit. Yeah, that one's probably likely to fit. Of course, it also depends on whether the conductor can fit down inside. So you should strip it so it just goes to the end, you know, almost peeks out. And if it peeks out too far, you can always strip, you know, cut it off. So it's probably better to be a little bit too long than too short. So I just stripped off the insulation there, and just try that. Yeah, that fits in, and you'll see, hopefully you will see, I don't know how well, yeah, you can just about see that it's just there. And this tool requires no adjustment whatsoever. It costs about, I think it's 12 or 14 pounds, including all of the bootlace crimp ferrule things. So really good. Let me just show you close up this. I'll just squeeze it. It's got a ratchet mechanism and it goes like that. Okay, really good. I've used it a lot actually, and but only in like the last month or so. So I can't say that this will be working in a year's time, but over the last month I have used it a lot. So just squeezing, it's really easy to squeeze, no straining on that at all, and it's pretty neat. Okay, I've got, you know, if I buy junk off eBay or AliExpress or whatever, and I think it's junk, I will tell you it's junk. I'm not making any commission from this. This is actually genuinely quite good. Okay, so let's just do a couple more of those. So we're going to use those grey ones, and I do find that it's helpful if you just give it a little bit of a twist just to stop the strands. Particularly, I've got so many different pairs of glasses. Like I've got another pair of glasses there. Those are my reading glasses or fine work glasses, which I should really have on now to do this. But I'm also looking at a computer screen in front of me, seeing what I'm videoing. So yeah, I'm struggling, visually struggling. Now that was a bit there. So you see the conductors were a little bit too long, but I'd rather be too long than too short. So what I'm now going to do, this is just my bin, so I'm just going to trim those off. Can't focus. It's going to focus. Hopefully, if it doesn't focus, it doesn't matter. I'm sure you get the idea. Let's just try again. Yeah, that's it. Okay, so too long is probably better than too short. We'll do one more. You can see it. I mean, obviously, the more you do of these, the more accurate you're going to be, and less trimming. But you know, it doesn't really matter for what we're doing. So I give a little bit of a twist as I'm doing it. Sorry, I also sometimes I take it away from the screenshot so I can actually see what I'm doing. But there, hopefully, a little bit too long. Not too bad though. I think we could suffer that one like that. So those three are now terminated. Okay, remember that is the power cable, the power lead, and then we can have the beauty of this. Okay, so what we're going to do, let's wire up the protective earth before we forget about it. So I just flipped that little latch thing up there. Now, like I say, you could easily manage without those crimps, but it gives a really neat job like that, and I like it because then, you know, I can repeatedly take these in and out, which is what I'm going to be doing on this. Okay, so there. So now I've connected those two up. Okay. Personally, you know, once I've done all this, I would cable tie around that, so you know you can't strain on it at all. We need to connect. This is going to be the neutral. That's the neutral as well. In the UK, the brown is going to be the live. So we need to connect those two together. So let's do that. It makes it really easy having these. Okay, so they're now together. And then we've got the, like I said before, we're going to have one of these connected, or one of these pairs like this. Those are going to be connected together. And then we're going to have the capacitor from one side to another. Let me just see if I can just grab that drawing again. Okay. So let's do that. So they're connected. And that one is. But now what we need to connect a capacitor. We need to connect a capacitor. Remember, that's the incoming live, the brown there. We need to connect a capacitor across these two windings. Okay, so that's what we're going to do next. So there's our capacitor. And there is a discharge or bleeder resistor across the capacitor. It definitely doesn't have a voltage across that. I have used it recently, but it's we're clear. I need to just, sorry about that, need to just grab some wire. So we need to just wire up something for that capacitor. So let's cut ourselves a little bit of wire. Let's make the leads the same length, like so. And I think this wire is slightly thicker, not intentionally, but slightly thicker, a heavier gauge than that. So we'll probably find that the grey ones don't fit. Let me just quickly try, but I believe that they don't. No, they don't. Okay, so we'll step up to red this time. Yep, they're a nice fit. So I'm going to put that in there. I'll give it a little push on the white wire just to make sure it's in there. There we go. I'm going to do both ends. Once again, you don't have to have these on here because the Wago connectors definitely don't need it, and to be honest, also you don't have to have it at the capacitor end either. But it just means that first of all, I can guarantee that I'm not going to have any unwanted strands sticking out anywhere, and also makes it nice. And I'm going to be connecting and disconnecting. So there we go. That was nice and quick. We'll do another one. Now, I don't know whether you heard that, but for whatever reason, I could hear like a slight tearing, and I cut off a strand. I don't think you can quite see it there. And even though it's just one strand, I don't find that acceptable, so I'll just trim that and I'll just redo it. So it's just probably just like the angle I had the wire strippers. You get a feel for it and you can hear it, even though my hearing is probably not the best, but I can hear it when it's not quite right. There we go. And actually being able to hear it is probably useful when your eyesight's not as good as it used to be. As I say, I could easily just change over my glasses and then I'll be able to see what I'm doing with the wiring, but then I won't be able to see what's on the screen in front of me. It's the eternal problem, I tell you. But anyone of my age is probably going to understand the problem there. Okay, so we've done that. What I'm then going to do is, let's just close it up, well, not close it over. Let's just grab a screwdriver, lean over, so. Okay, so let's get these in here. Okay, so that's one. Okay, so now that's my capacitor. Now, as a safety feature, I suppose you could call it a safety feature, we are going to put this back on. It doesn't make it safe as such, but it does reduce the exposure to risk. So, really this capacitor needs to be placed in a box or something like that, or in a machine where you're not going to be able to touch it. So that hood, or whatever you want to call it, boot, I suppose, rubber boot, pops over there. There we go. Okay. Obviously, if you wanted to electrocute yourself, you can still possibly gain access to that. I mean, I just would want to keep away from that personally. And then it doesn't matter, the capacitor is not polarized, so let's just put this in one side. Just take that out. I need to, okay, make sure that's in. And yep, this is going to be onto the other winding. Okay, like I said earlier, if I were going to be using this now, I'd want to bunch all those together, and I'd want to put a cable tie around so nothing can be, pulled out. Let me just have a quick visual check, just to double check that I've not done anything silly. So we've got the two earths going together, so they're tied together. We've got the incoming neutral, the blue, going to the black of the motor, and then we've got the power, which goes to one winding directly, and then via a capacitor to the other winding. Okay, so that looks right. So I'm going to turn this around. You probably aren't going to be able to see the direction of rotation. Now I'm safe to take this off. You're probably not going to be able to see the direction of rotation until it's slows down, I would guess. But as I said earlier, I think we can actually get it to change rotation by just flicking a couple of wires around. So let me just get this plugged in a moment, and it's spinning and off. And I don't know whether you were able to see that, but it's spinning that way. Okay, so next time I want it to spin the other direction. So I'm just going to remove, and then what I'm going to do is just take the live and put the live in the other side, like so. Okay, so now that goes directly to that winding, and then the live goes via a capacitor to the other winding. Okay, so this time I'm expecting the motor to rotate that way around. Okay, so I will plug back in, and it does. Okay, so it's this time it was going that way round. It would be interesting to see what happens if we actually disconnect one winding once it's spun up. But however, I can hear in the background my kids have just stopped watching a TV program, so no doubt they'll be dying to come out here in just a moment. So I'm going to stop the video there. I do hope you found it useful, and if you did, please give the please give the video the thumbs up. Thanks very much for watching. Goodbye.